Hello? Hello, can you hear me?
Hey, can you hear me?
Yeah, I can hear you now. Good.
Hey, how's it going?
Good, how are you?
I'm pretty good, thank you. So yeah, by way of introduction, I'm a software engineer at Microsoft. The team I'm on, what we're doing is that we're building a container to run SQL Server inside of. The idea being that SQL Server will run as a Windows process inside the container, and the container will handle all the system call translation outside of the application scope.
Okay.
So yeah, that's a little bit about myself. What's your background?
Okay, I'm also a software developer at Microsoft, and I
Oh,
am
nice.
working with the Azure Tools team right now. And the tool which I'm working with, it helps deploy the user services on Kubernetes in Azure,
Mhm.
and we
Right.
provide um, a developer environment, and that gives a iterative remote debugging feature.
I see.
So
I see.
yeah, that's pretty much about it.
If I may ask, which building are you in?
18.
Oh, you're in 18. I see. I'm in 43, so across the
Okay.
street.
Yeah, actually, yeah, a lot of our folks were in 14 as well. First 43, like earlier. I think it's
Right, right.
Georg's
We
also.
recently moved there.
Okay. Okay. Cool.
Okay,
From
cool.
Yep.
Um, I guess like what I have on the agenda is to basically treat this like a mock phone screen for Microsoft. Um,
Okay.
having said that though, because you're an experienced engineer, I
Mhm.
guess the disclosure would be that the phone screen for experienced engineers it's slightly different. So the thing is, for new grads, what they look for is basically, how quickly you can solve problems and things like that. Right? So
Okay.
they're judged on three criteria essentially. There's problem-solving skills, coding skills. Basically, can they express themselves in code? So they say an idea in words, and then can they sort of express the same idea in code, that sort of thing. And then communication, right? So these three metrics are used to judge new grads, right?
Okay.
Um, so the way it works is that each interviewer gets assigned a pool of candidates. So say 10 or 15 candidates during the peak season, like right now. What will happen is that each interviewer will basically get 15 candidates, and they can only recommend that two or three candidates be flown out for the on-sites. Right? So it's a ranking-based system.
Yeah.
So regardless of whether the questions are easy or hard, what will happen is that um, uh, or a candidate is judged based on how their peers do.
Mhm.
For experienced candidates, however, the method is slightly different. The pool is smaller because you apply for specific roles, right?
Yeah.
Um, so only say 4 or 5 people will apply for a particular role, a particular team. So the pool is smaller, and the metrics that they have an additional metric that they use to judge experienced candidates. Um, and that is basically, are they a good fit for the team? Like, what value can they add to the team? So the emphasis is less on your algorithmic prowess, if you will, and the emphasis is more on what value do you bring to the team.
Got it. Yeah.
So because they don't, depending on what level, say for example, at Microsoft, if somebody's hired at like a senior engineer level, they expect the engineer to start contributing from day one, right? So there's a ramp up period. So I guess
Mhm.
the metric that they'll judge you most critically on is basically how much of a quick learner are you for experienced candidates. Um, But if you're interviewing for, say, a software engineer 2 or software engineer 1, then the process would be slightly different. They would expect there to be a ramp up period. So they wouldn't expect you to sort of, be able to think on your feet and things like that.
Yeah.
But yeah, that's a slight difference, but I just wanted to sort of make sure that, we're both on the same page about that. I won't be able to replicate that here because, we don't have any of that, but uh, we'll go through like
Yeah.
a bunch of algorithm problems and all that.
Okay. That sounds good.
All right. So if you have any questions, please feel free to ask at any point. But if you don't have any questions at this point, I guess, let's get started.
Yeah. I think the questions which I usually have is mostly about the position and the company and how does the process goes, but that doesn't hold here. So I
Yeah.
believe, yeah.
I mean, I can make something up, but it's not going to help you. But yeah, that's a good thing to ask at this.
Yeah.
All right. So if you could go ahead and pick your language, let's get started.
Yeah, I would go with the C sharp. I'm comfortable with that right now, yeah.
Sure. So I guess the first question we'll be looking at
Mm-hmm.
it's a list manipulation problem. So you're given a list of integers,
Okay.
L, and a number K. You're
Okay.
being asked to write a function to partition L into elements that are strictly less than K, equal to K, and strictly greater than K.
Okay. So when do you say elements, what do you mean by that? Like into smaller sublists?
Um, I mean, so the thing is, like, you're given a list, right? So the idea is to create segments inside your list. So when you say sublists, I guess, like, I don't mean you cannot create new lists. If you could create new lists, this problem would be trivial, right?
Okay, you're saying just okay, like swap the
Instance,
values within the same list.
yeah, and make sure that you have like 3 segments, right? Each segment does not need to be sorted, but overall, like there has to be a segment which is full of elements that are strictly less than k, followed by a segment of elements that are equal to k, followed by a segment of elements that are strictly greater than k. Now, within
Okay,
each segment, the elements don't need to be sorted. Sorry, go ahead.
got it. So I was just okay. Can I write? Um, yeah. So I was trying to give an example here to see if I have got that correctly. So if I say it is
Sure.
4, 5, 7, like 3, 2, 1, 0. Actually, so and if the element is k, oh sorry, the element is 3,
Hmm.
the k is 3, what I mean. So then you're saying I should have it like 2, 1, 0, 3, and 4, and 5. Is that correct?
That's correct. Hmm.
Okay. Okay, got it. So I don't have to partition it with something else as well, right? Like a space or something, like an empty.
No, no. This is
Okay.
a
Just a
theoretical
logical
partition.
partition.
Yeah, logical partition, if you will.
Okay, got it. So, taking the same example for now. Okay. So what I think,
So I just want to suggest an approach. So you could always sort the array, right? And it would
yes,
automatically be partitioned. And the best sorting algorithm that you can use is probably merge sort. That will give you n log n, right?
yeah, that's
But
correct. So yeah,
I guess,
that would be one solution definitely.
but I guess we're looking for something better, right? So because sorting gives us that's also trivial if you think about it, right? We're doing extra work. Each segment, each partition does not need to be sorted within the partition, right? So merge
Yeah,
sort,
exactly.
we
So
can use
that's
that,
what I
but
was going to,
yeah,
because you said it does not need to be partitioned. So yeah,
yeah,
it does not need to be sorted. Like this does not need to be 0, 1, 2. It can be
yeah.
2, 1, 0
So
itself.
merge sort would be wasteful in that sense, right? So
Yes,
to create these partitions, I guess the runtime that we're looking for has to be better than n log n, right? Because we
so
can,
that would be n, I believe.
right?
Yeah, that would end up as n, I guess. So yeah, like.
Yeah. So we're looking for an n, like a single pass solution.
hmm So what I will do here is I will try to traverse this particular array, like the first one, and I'll try to. If I'm going for n, then I will just traverse it and try to swap the values according to k.
Okay.
So let me get that. So.
That would work, but I would encourage you to think about it in terms of an invariant, right? In your array, from the very beginning, so you have an array of elements, right? What I would
Uh-huh.
recommend that you do is think about it in terms of having these logical separators, where basically the first separator will tell you where the partition of smaller elements ends, right? The second separator will tell you where the partition of equal elements ends. And the third separator will tell you where the partition of larger elements begins.
Yes.
So something like this. If you have an array, right,
Uh-huh.
to create like these logical partitions, right?
Yes. I get
If you
that.
do that, basically the idea is to the trick here is that you have a region of unsorted or unseen elements. Like this region here is full of elements that you haven't discovered yet, right?
Uh-huh.
So I guess what I'm suggesting is a way to sort of keep track of these three partitions using pointers in your array.
Yeah.
These are indices at the end of it, right?
Uh-huh.
You can keep track of where the index for each partition begins and basically perform the swap accordingly as you're moving through the array.
Okay. So if we do that, let's see. So for example, if I go with the, for example, if the smaller, let's keep every pointer pointing to the first element. So
Not every pointer though. The larger would have to begin at the end.
okay, so it's like 453 210. Yeah. So the smaller will, I will have it as at the space 0, and
Mm-hmm.
then I can have the larger one at the last 0 1 2 3 4 5. Yeah. I'm actually, yeah, let's assume the mid will be 3 for now.
How will you know that though?
I'm just taking the half of that right now, half of the length of the array.
No, but then in your array, the mid basically tracks the end of the section partition where the elements are equal to k are stored, right?
Yes.
In your array, you don't know how many elements that is.
Yeah, that I agree, but I'm just trying to go with these initial values now and then calculate it over when I will traverse it through.
Sure, sure. I don't see how that will work, but sure. I mean, yeah.
No, I'm just giving it a try.
So,
Maybe I'll change my approach a
sure,
little
sure,
bit
absolutely, yeah. So,
while I'm going
yeah,
through the
sure.
algorithm. So yeah,
That's
uh,
completely fine. Yeah.
yeah. So like that's what I have as an initial thought in my mind. So I will prefer,
Mhm.
updating that when I go forward
Sure.
with the item. So okay, so these three things I'm just going with right now. So I will check. Yeah. So let's see. I will see 4. The first value is 4. Like when I'm traversing through the array, the first value is 4. So I will see that is greater than the value 3. So our k is 3. So that is greater than the value 3. And so I will move this, swap it with our larger value. Okay. So if I'm, so let's swap it with our larger value element 0 1 2. Sorry, 0 5 3 2 1 4.
I'll be right back. Give me 1 minute.
is 0, 5, 3, 2, 1, 4. Minus minus. Minus 1 and minus minus. So that is equal to 4. Still check on. Okay.
Hey, so where are we at?
Okay. So I'm trying to go through. I'm doing a dry run of the algorithm I have in mind. So I can just take you through that. So let's see. So in the starting, the case 3, assume s is equal to 0, the largest one is equal to 5, the end of the array. I'm taking middle is equal to minus 1 right now. I'm still, trying to figure out the middle one.
Uh-huh.
Okay. So let's see. When I come here, my s is equal to 0. That was 4.
Okay.
So when I come here, my s is equal to 0, that is 4. I check the value is greater than k. Then I will go do a swap of 0 and I'll move it to the L value. So I get 0, 5, 3, 2, 1, 4. So now I will do L minus
Okay.
minus because the swap has been done and there is a larger value at the L position. So I'll do L minus minus. So L is equal to 4 right now.
Okay.
Okay. So again, my S is still 0. I'll still check the same condition again. If it is less than K, then I will do S plus plus. Otherwise, again, the same thing, the swap, which we did earlier. So right now here, the S is equal to 0. So it is less than K. So we will do S plus plus. Our S will be 1. So now I will do the same algorithm. I will check S is, if the value at S is greater than or less than 0. It is less than 0, leave it there. If it is greater than 0, I will do the swap again. So that will be 0 with L. So the L value is 4 right now. 0, 1, 3, 2, 5, 4. That is what I will get right now after the
Okay.
swap. So here my S is equal to 2. No. Yeah, my S is still 2. So I checked it. It is less than our 3 thing, our K, and then I will do S plus plus. So my S is so my S was 1. Now my S sorry becomes S equal to 3. Sorry, 2. So in this situation, I will check. So on the S2, it is the value is uh, greater than is equal to K. And then if my mid is equal to minus 1, I will assign mid to this value. So I'll have my mid over here.
So I would say like the mid that you have, right? You can use that to iterate through the array. Use that as the current index, if you will. You do that,
Okay.
right, then it becomes much more straightforward. The same idea that you have, but
Mm-hmm.
using mid as your current index.
So I was using
So
S
what you
as my current index. So
you're using S, that's fine. But what I'm saying is, yeah, you can use S, but what I'm saying is you're gonna have to adjust your mid accordingly. So the idea is that, okay, so there are three cases, right? The current element is less than your K, right?
mm-hmm.
In which case it should be swapped with the smaller, right?
Yes.
And your current pointer should be incremented, and your small pointer should be incremented as well, correct?
Okay. Got it. Yeah. So yeah, I think, and I can
So the
just keep
mid,
the midterm there itself and not swipe it with anything, and just move to the next element.
yeah, yeah. So there are three cases essentially. So the one case is that the current is smaller than k, right? The other case, so when current is smaller than k, you swap it smaller and you increment both current and smaller, right? You move your walls up.
Yeah.
Now the other case is where current is strictly greater than k, right? If current is strictly greater than k, all you do is you swap with the larger,
Mm-hmm.
but you decrement your larger, but keep your current the same. That's the trick, right?
Okay. So I think I have kind of yeah, that in mind now. Like I got that how to handle the mid thing. So
Yeah, let's write some code. I think it would become
okay.
clearer as we write
Yeah.
the code.
Yeah, we can start with the code. So let's I'll create a method. There'll be partition, and this will take an array. So I will declare three elements. Mid is equal to 0, start is equal to 0, and end is equal to array dot length. So excuse me. So actually I will just go through the loop. I'll set that condition later on. What I feel the condition would be if mid has hit larger. That's what I feel. If mid is, so till that time we will still not going. If mid is equal to larger, then I think we have achieved. So that's what. So
Right.
if yes, so let's see. Okay. So what I will do is I will go through mid. If array of mid is less than, oh, there should be one more element, k. Okay. Okay. So if array of mid is less than k, then I will write another function of swap. I'm just assuming it exists. So I will swap array of s and array of mid. So 4, 5, 3, 2, 1, 0. But else, if it is greater than k, then I will do with, oh, I can do it as L. Okay. So okay, let's see if that works. And let's have static y. So if we have first index I index, I'm just taking different parameters here. I'm trying to. So j, either I can return it or I think I can use a reference here. Reference. Oh, okay. So if I just want to go through the algorithm once and see if it works. I will take this example up there. Okay. So I have four. So it is going. So the mid is 0, the S is 0, and the L is 5. Um. So then the mid is less than larger. I'll go inside. I will say if so if array of 0, that is 4, is less than k, it is not. It is greater than k, then I'll swap it with L. So the L
Mm-hmm.
is 5. So I'll swap it with like
I
this.
think you're missing two things. Looking
Pardon?
at your function, you're missing two things, right? One is that what you have to realize is that you are starting with your mid at 0, right?
Mhm.
So the thing is when you encounter an element that is strictly less than k, the idea is that you have to increment your mid as well. Like you're not incrementing your mid anyway.
Yeah. That I will do at the end. Like I was thinking of doing it here.
No, that's you cannot do that there because you're not supposed to increment the mid if
When it
you're
is.
like for this case
Yes. Okay.
because you might run into an example or a case where say for example you have 5 here right, and then some elements and your larger is 7. L is equal to 7 and mid is equal to 5. Okay. Now your k might be 6. Actually, k might
Yes.
be 4. Right. Actually, let's say k is equal to 6. Right.
Mhm.
Or 4. If k is equal to 4, then your array's mid is strictly greater than k. Right. And you swap the two. Right. So you take this and you swap. Now your mid is 7. Right. And your larger is 5.
Yes.
But then you decrement your larger. So your larger becomes something else. Right. But your mid should still be
The same.
or the same because you might have to swap it again.
Yes.
So in this case, you increment the mid. In the other case, you don't. And the other case that you're missing is that um, if
If it is
this
equal,
is the
then I
case
have to
where
just increment mid. Yeah.
exactly.
Yes. Yeah. I was about to come to that because I was the other algorithm I had in mind was the use of S. So I had this one stuck in my mind.
Oh, I see. Okay.
Yeah. So because if you see in the lower like an example I've taken, the same thing I'm doing.
Mhm.
If it is S, then I'm incrementing S. But in case of L, I'm just decrementing L and not incrementing S. So that's why like if we just switch that with mid,
Right.
so the same thing holds here. So
Um,
in the case of greater than, we don't increment mid. Yeah,
right.
and this
And
might. Minus
Your
one.
L has to be -1,
Minus one. Yes.
and this will work now. Yeah.
Yeah. I was like, while I would do the dry run, I would have like fixed some things.
No, of course, of course.
Yeah.
All right. So
So
yeah, we're almost out of time. Before we move into the feedback portion, I guess let's quickly go over the runtime and the space.
sure. The space will be constant because we are just
Mm-hmm.
using space for swapping, nothing else, I
Right.
believe. Yeah, and the time would be it's uh I'm traversing like sequentially, so I think it's n only. It's yep,
Yeah, it will be all
yeah, okay,
then. Okay,
yeah,
so that's good. It's gonna work. Now, in terms of feedback, right? So I think the biggest issue I see is that, um, and I'm completely convinced that you can solve this problem and all of that, right? But the biggest issue I see is with the time management.
okay,
This question is definitely an easy question. Easy question in the sense of like a lead code easy question. Why? Because this is like the partition phase of quicksort.
mhm,
So the K that you're giving here is really the quicksort pivot, right?
yeah, yes,
So this is something that should take you at most, say, 5 to 10 minutes, something like that, right?
okay,
So if you take like 20, 25 minutes to solve this problem, what will happen is that you will severely restrict yourself or hamper yourself from demonstrating your skills in some other areas, right?
okay,
I like the way you solve the problem, going for a dry run and then sort of coming up with the code, but that is a very time-consuming process. If you can do that faster, that's good. But if
okay,
you can't, then I would recommend that you actually go straight into the code. I don't mean like your algorithm has to be perfect from the very beginning. I mean that you'll have a version one, right? And then maybe you'll do a dry run and change some things and things like that. So what I'm trying to say is that I think you started coding really, really late.
okay, got it. So like I gave you the example in the starting, so you are like suggesting me to directly jump into a code and then talk through that, right?
Either that, or if you're going to go through an example, do it much, much more quickly. I think you took like 10 minutes on that example, but
Yeah,
at the
yeah.
end of it, we didn't really get any information out of that example, right?
Yeah, I agree. Okay, got it.
So what I would say is that I think you have to be more economical with your time and really analyze, only spend time in areas that will help you
Hmm.
sort of move forward in terms of solving the problem.
Got it.
But problem solving wise, I think you're in good shape. C sharp, like being able to express yourself in code, I think you're in good shape. You're using some fancy C sharp stuff with references and things like that. So I know for a fact that you're comfortable expressing your ideas in code, right, in your language of choice. So that is great. Problem solving wise, like the basically I knew from the very beginning that you were on the right track. That by running through a few examples, you would be able to sort of come up with a solution. I could get that, right? But I also got the feeling that you were a bit rusty, right? That you hadn't done these things in quite some time.
Yeah.
And that shows, right? So being able to come up with the algorithm is one thing. Being able to do it really quickly in a time efficient manner with somebody looking over your shoulder, that's another, right? So it seems to me that you're a little bit rusty, which is good. It's good in the sense that it can be fixed easily, just by practicing more. But I definitely do think that you need a little bit of practice when it comes to the interviews. The speed is a bit of an issue.
Okay, got it. Sure, I'll try to take care of that. Thank you.
Yeah, so I know that's a bit harsh, and um, we've all been there, right? But there are no consequences here, so that's great. So if you have some time, if you spend like an hour every day solving these problems, right, for 4 weeks, then if you come back and do this again, or if you sort of just you'll start thinking more efficiently, and that will show. That
Okay,
will show.
got it.
But yeah,
Okay.
I mean that's the feedback I have. Do you have any
Yeah,
questions?
that's really good. Like, thank you for that. That was, yeah, that was a good feedback.
Yeah, you're welcome. Anytime. Do you have any questions?
Um, so yeah, for the like interview point of view, so I always had this question like if I'm going through the so do you guys suggest writing the just like compilable code in the first run and then going for like or like if I write some code and now I see oh there's an issue if I like while I'm doing the dry run I found some bugs and I fixed it. So
Mhm.
does that count as a negative thing? Like should I have not had
No,
those issue in the first way
in general,
run?
no. In
Okay.
general, no. But um, like your code would have compiled from the very beginning, right? I think
Yeah.
your syntax was great. Your syntax, would have worked. I think you were missing a couple of cases, so your algorithm wouldn't have worked, right? So they're not expecting like that from the first line of code to the very last line of code that your code should be perfect. That's something that's not expected. What's expected is to basically break the problem down into small pieces and solve each piece in turn. If you miss a piece, that's fine. Come back to it and solve it, right?
Got it. Okay.
But I think the approach you took was to basically look at the whole problem and tackle the whole problem at once, right? But if you broke it down into smaller pieces, once you had the three-pointer approach, you were set. You had a three-pointer approach. Now, how do you move the pointers? That's a different question. One is the approach. The approach was the three, you had to use three pointers. The other was how do you manipulate the three pointers? That's a different question. Now, for how to manipulate the pointers, there were three cases, right? Like with any integer, there are always three cases: less than, equal to, greater than, right?
Yeah.
How do you handle each case? So what I would ideally like to have seen, is to basically is for you to break down the problem into these two questions and answer each question in turn.
Got it. Okay.
Does that sort of make sense? Like how the problem can be broken down into smaller pieces?
Yeah, 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 I agree with that. Yeah, I could have like started that way as well. But in the starting while I was giving you the example, like what my approach was, like while I was explaining you
Mhm.
the example down there, I was
Right.
kind of getting my algorithm, like I was trying to build my algorithm because, of course, like I could have jumped in the code, but it wouldn't have given me anything because I didn't have anything in my mind. So I was like
Right.
going
No,
through the
of course.
example and trying to build an algorithm which I can write.
Right. Right. Of course. And that makes sense. If you have to do that, definitely do it. But you might want to sort of be a little bit more efficient when doing it with
Yeah,
respect to
yeah,
time.
yeah. Got it.
Um, but also when you're thinking about the algorithm, like, just take a simple example. I think the example you took was too complicated. You could easily have come up with the algorithm using an element that had just using a list that had just like three or four elements, right? And that would have illustrated the main point.
Okay.
So
Sure.
what I'm suggesting here is that not to sort of come up with the algorithm using a specific example. Think of a general example, right? Think of an
Okay.
arbitrary example, but that illustrates the main point. So you see how on line 41 or 40,
40. Yes,
how
yes.
how we did that. So you'll see that we only used two elements, right? But we came up with a very important idea.
Okay, got it. Okay.
Because what I often see is that people sort of start with an example and then they write an algorithm for that example, but then when they try to sort of use a different example, it doesn't work because the algorithm is tied to that one example.
Yeah, even like yeah, I have had that issue sometimes. So
So you
you're
want to
suggesting
think
like
in
go
general
with a
terms.
general approach, not a specific example.
Yeah, yeah. So go with the general approach. Take a step back, look at the bigger problem you're trying to solve, identify the main points of that problem.
Okay.
That is what I would recommend.
Sure. Yeah, that makes sense, and yeah, I'll keep that in mind, and I'll try
Cool.
to do that most of the time.
So, any other questions?
No, that'll be all for now. I think yeah, I got most of my questions answered already. So yeah, that's thank you for this
Yeah, well,
session.
no problem. And it was great talking to you. Thank you for doing this, and hopefully we can keep in touch. And if you're still practicing, I'm not sure. Are you actually interviewing like internally or externally?
I'm actually looking for internally first, and then if I'm looking for a team change right now. Not like, yeah, I'm just exploring right now, and in case, so I just started practicing and everything. So in case there is
Right.
a internal switch I do or an external switch, so I'm not like, yeah, I haven't. There's nothing like finalized or decided yet.
Okay. Well, if you
I'm
would
just
like to, the thing is, I'm also looking externally. So if you would like to sort of get together sometime and solve problems, I'm open to that as well. And
okay.
hopefully
Yeah,
we can keep in touch.
that sounds good. Not yeah. So you which
Cool.
position are you at right now? Like which level?
I'm at level 61.
Okay. So even I'm
If I may ask,
yeah, even I'm at level 61 right now. So yeah, same.
I see. I see. Okay. Okay. You said tools, right? Azure tools.
Yes, Azure tools.
Right. Cool. Cool. Well, hopefully we can keep in touch, and I wish you all the best. And if you want to solve problems together, let me know.
Yeah, we can do that. Thanks.
Cool. Sounds great. Well, nice talking to you, and all the best.
Same here. Thank you. You too.
Thanks. Take care. Bye.